I'm going to talk about expressions and equations. I'll assume that you're familiar with the basics of variables. If you're not, I would encourage you to first watch my introductory video with respect to variables. All right? Now I'd like to discuss expressions. Expressions are sets of operations involving numbers and or variables. The expressions are sets of operations involving numbers and or variables. For example, the number 3 is an expression involving one number. The variable y is an expression involving one variable. M plus 2 is an expression involving one variable, one number, and the addition operation. All right? Now, you can have expressions with several operations and several numbers and even several variables. So, for a more complicated example, how about a plus 2b minus c squared all over d minus the square root of e. Okay, that's a valid expression. Now I'd like to talk about the evaluation of expressions. Evaluating expressions means to substitute values for variables. Evaluating expressions means to substitute values for variables. For example, let's evaluate the expression x plus 1 with respect to the following values. Let's evaluate it with respect to x equal to 2, x equal to 10, x equal to minus 3. Okay, and you're allowed to evaluate the same expression with respect to different variable values. If I evaluate it with respect to x equal to 2, I will get, and so to do that, I'm going to substitute the number 2 in for the variable x. That's going to give me 2 plus 1. So I say that the expression evaluates to 3. If I substitute 10, I'm going to get 10 plus 1. So I'll say that now the expression evaluates to 11. Okay? And then finally, if I substitute minus 3 for x, I'll get minus 3 plus 1. So I'll say now the expression evaluates to minus 2. I would like you to do some examples if all of that made sense to you. Would you please evaluate x squared minus 4 with respect to x equal to 5? Would you evaluate a plus 2b with respect to a equal to 1 and b equal to 2? And would you please evaluate u plus v over w plus z with respect to u equal to 4, v equal to 6, w equal to 1, and z equal to 4. So pause the video and do that now, please, if you like. Okay, I'll go ahead and do it as well. So when I substitute 5 for x in the first expression, I will get 5 squared minus 4, or 25 minus 4, so I'll say that the expression evaluates to 21. For the second expression, when I do the substitutions, I will get 1 plus 2 times 2, so that the second expression evaluates to 5. For the last expression, after I do the substitutions, I'll have 4 plus 6 all over 1 plus 4, and that will evaluate to 10 over 5, or 2. Okay? Now, let me discuss equations. So what are equations? Equations are statements of equality between two expressions. Equations claim that two expressions are equal. All right? For example, one might claim that y minus 4 is equal to 10, or that 1 plus 1 is equal to 2, or that a plus b is equal to c minus 4d. Okay? Now, if both expressions in an equation don't involve variables, it's pretty clear what it means to claim that both expressions are equal. But what does it mean to claim that two expressions are equal when we haven't stated the values that we're supposed to substitute in for the variables? Okay? So there's actually a game that is played with equations. Equations, they limit the values that you're allowed to substitute for the given variables. So a lot of work in algebra is determining what are the values that we can substitute for the variables in an equation that make both expressions evaluate to the same number. Okay? For example, the first equation that I wrote, y minus 4 equals 10, I am only allowed to substitute 14 for y. Okay? Only with that substitution will the left side evaluate to 10. Any other number, and the expression will evaluate something such that both sides are not equal. See the problem? Okay? Now I'd like you to think about the following question. If I had the equation 2x plus 5 equal to minus 7, is x equal to minus 6 a solution? Okay? What about if I had the equation x plus 3 equal to 2? Is x equal to 0 a solution of that equation? Okay? So to answer both of those questions, I simply do the substitution and see if both sides of the equation, both expressions, evaluate to the same number. So when I substitute minus 6 for x, I get 2 times minus 6 plus 5, and that's equal to minus 12 plus 5, which is equal to minus 7. So yes, x equal to minus 6 is a solution. See how that works? Now for the second exercise, I substitute 0 in for x. So on the left side, I'll get 0 plus 3, and that's equal to 3, which is not equal to 2. So x equal to 0, that one is not an expression. Okay? So let me have you do some similar exercises now. X squared minus 9 equals 0. Is x equal to 3 a solution of that equation? And how about 7 minus h equals h plus 5? Is h equal to 1 a solution of that equation? So pause the video and try to answer those two questions now. So I'll go ahead and do them as well. So for the first equation, I'm going to evaluate the left expression and get 3 squared minus 9, which is equal to 0. So yes, x equal to 3 is a solution. For the second equation, I'm going to substitute 1 for h. 7 minus 1 will give 6 for the left side expression. For the right side expression, 1 plus 5 gives 6 as well. So yes, that one is also a solution. Okay? Now, sometimes you're not given a solution or a candidate solution. Sometimes you need to determine the solution. Now, you don't have a lot of tools in your tool chest to solve equations. So you aren't much, you don't have any, pretty much not much more fancier tools than just trial and error or guessing, educated guessing at this point. Okay, so just do your best. Can you find the value to substitute for x that makes this equation true, that keeps this equation, so that both expressions evaluate to the same number? Okay. Also, can you find the value of the variable that makes this second equation, both sides, both expressions evaluate to the same number? And then finally, can you find the value of k such that the third equation evaluates to the same number? Or the both sides, both expressions in the last equation evaluate to the same number. All right, so pause the video and work those out now if you like. Okay, so I'll go ahead and work them out as well. So by trial and error, you may have seen that x equal to 0. If you substitute 0 for x, both sides will evaluate to 0. So that's a solution for that one. For the second equation, by some method, you may have determined that m equal to 24 works. If you evaluate the left side with respect to m equal to 24, you'll get 6, which is equal to the right side expression. Okay? Now the last one, and I'll close with that one, that one's kind of interesting because watch this. You may have noticed that k equal to 9 works. If you evaluate the left side with respect to k equal to 9, you will get 81. You may or may not have noticed that negative 9 will also work. Okay? Negative 9 squared is also 81. So that's an example of an equation that has two solutions. Okay?